Okay, so what we're going to look at now is a non-square Hungarian algorithm question. This one is also maximizing. So we're using two of our new sort of techniques that we need to understand. So in this case, it's a normal situation. We've got 4 shifts left to fill at the supermarket, and there's 5 staff available for those shifts. So someone's going to miss out. The matrix below shows the staff and their ability level on each shift out of 10. We need to determine the best 4 staff to take the shifts. Now, this is a maximizing problem because we're trying to have the best ability spread over all of these shifts. So we're doing kind of like the opposite, including that opposite step that we use in maximizing. But there's also another step that we need to include due to the fact that this is a non-square matrix. So the first thing that we're going to do is identify our largest value in the matrix, which is 9. And we're going to subtract every value in our matrix from that 9. So 9 takes 7 is 2, 4, 3, 2, 0, 6, 1, 2, 5, 3, 3, 2, 1, 3, 4, and 1, 2, 3, 4, and 2. Now, the other thing that we need to do, the fact that this is a non-square matrix means that we need to add in what we call a dummy column. Now, if we had, say, 4 rows and 5 columns, we would add in a dummy row in that case. But the main thing is we're just trying to make this square. So we're going to add in all these zeros here. Now, what that does, straight away, you will notice that we have 0 as our minimum in each row. So we're not going to worry about subtracting anything from the rows as our minimum. We're just going to look at our columns now. So obviously nothing in this one, nothing in the first one. We've got a minimum of 1, a minimum of 1, and a minimum of 1. So let's draw that in. So we've got our regular first column that did not change. We've got our dummy column that did not change. Our second column goes to 5, 0, 1, 4, and 2. We go to 2, 1, 0, 2, and 3. And then we go to 1, 3, 2, 1, and 0. If we have a look at what we've got here, before we even start drawing our lines to determine whether or not we can solve this straight away, we see that we have got all of these ones in the dummy column, and then we don't have any, we've got the exact same thing happening in row 4 and row 1. So that immediately should trigger you into thinking that we're not going to get a solution out of this, but we still need to use our algorithm steps to make sure that we can move forwards. So let's start by knocking out this one because that's definitely got the most zeros in it. We've also still got 2 zeros in this this row here. And then we've got 1 and 2. Again, it doesn't matter if you do vertical or horizontal. We're just trying to knock out as many of these zeros as we can. You will still end up with the same result. So from that, we have found that we've got only 4 vertical and horizontal lines when we need 5 because our matrix has got 5 by 5 or 5 rows and 5 columns. So therefore we need to use that next step, which is identifying the smallest value that is not covered, which is 1. We're going to add that to anything that is covered twice. So here, here, and here. And we're going to subtract that from anything that is uncovered. Anything that's covered by just one line is going to stay the same. So I'm going to start off by writing in all of those ones that are staying the same. Now I'm going to look at the ones that I need to add to. So I've got 2 goes to 3, 3 goes to 4, 0 goes to 1. And then I'm going to subtract 1 from everything else. So 2 goes to 1, 3, 2, 1, 0, 2, 1, and 0. So we're going to use our covering up with the lines again. So first of all, we can see there's still 4 in this one, so this goes first. We can see that the fourth column has got 1, 2, 3, so we're going to cover that one up. We can't actually do anything that covers multiple zeros up here, so we can straight away identify that 1, 2, 3, we've got our 5 vertical and horizontal lines as we require. What we're going to do now is look at which ones we can knock out first. And what you might start to notice is that we have a couple of situations where we could have potentially multiple solutions. So there is if we look at our first column here, we can see that that needs to go to this person here. So we're going to circle that one. Now, if that person is doing that job, then they cannot do this one over here. We look at our second column. This person must do this job, which means that they cannot be in the dummy column. If we have a look at the rest of it, we have got this third one where this person must do this job because they are the only person that is available for that job as well, which makes that dummy column taken away as well. Now, our final 2 columns, we can see that we've actually got 2 options here. So I'm just going to draw that on the remaining 2 algorithms just as circles in there. So we know that this is going to be someone, this is going to be someone's allocation, and that's going to be one. So those are guaranteed because those are the only people available to work those roles in the context. Now, we could also have this person working this one and this person missing out, or we could have this person working this one and this person missing out. Those are both valid solutions to our Hungarian algorithm structure here. So what we're going to do is look back at our original matrix, and we're going to overlay those results onto it. So Ellen is definitely going to do night fill. We have got Brittany definitely doing the bakery, and we've got Cam definitely doing the deli. Now, the 2 remaining people are Andre and Danny, and if we have a look at our 2 results here, we can see that Andre and Danny both have a rating of 7, which satisfies the fact that we could give either of them that role and either of them could miss out, but we will definitely still have the same staff ability maximizing on this as a result of this algorithm. So if we write down over here, we could have Andre on fruit and veg. We could have Brittany on the bakery. We could have Cam on the deli, and Danny misses out, whilst Ellen is going to do night fill. The alternative one, which I'll write over here on the left, is that Andre misses out. Brittany still takes the bakery. Cam still takes the deli. Danny takes fruit and veg. And Ellen takes night fill. It's always important if you get 2 solutions, you make sure that you write down the fact that both of them are possible.